Hello, my dear students. Today we are going to continue our discussion on organic chemistry. We are going to discuss the third type of aliphatic hydrocarbons. We are going to discuss alkynes. We are going to discuss their nomenclature and their physical property. And we are going to discuss the ethine or acetylene molecule, its preparation, and its chemical properties. So let us start. Alkynes. Alkynes are organic compounds have general molecular formula CnH2n-2. The nomenclature of alkynes. The name of the alkyne is according to the longest continuous chain as alkanes, but putting the suffix yne preceded by the number of carbon atoms nearest to the triple bond. For example, as shown in the screen, this molecule contains 3 carbon atoms, so its name is propyne. Another example, as shown in the screen, this alkyne has 5 carbon atoms and we have triple bond between the carbons number 2 and number 3, so its name is 2-pentyne. The numbering of the carbon chain starts from the nearest side to the triple bond, regardless to the position of the other groups. As shown on the screen, this compound is numbering carbon atom from the nearest carbon to the triple bond, and the triple bond between carbon number 1 and number 2, and its name and position according to the least number of carbon atom, so it will be 3-methyl-1-butene. As shown on the screen, this molecule also contains 4 carbon atoms, and we are going to start the number of carbon atoms from the nearest to the triple bond and its position to the lowest number of the carbons that have the triple bond, so its name it will be 4-chloro-1-butene. Now we are going to discuss acetylene or ethine that has chemical formula C2H2. The preparation in lab. The acetylene or ethine can be prepared in lab from calcium carbide, in which water is dropped on it as shown in the chemical equation that on the screen. CaC2 plus 2H2O gives calcium hydroxide and acetylene is produced. As shown on the screen, now water is dropped over calcium carbide and the acetylene gas is collected above the water, and here the acetylene gas is lighter than water, so it is collected above the water as shown on the screen. So my dear student, if you look at the screen now, the water is dropped over calcium carbide and the acetylene gas is passed over copper sulfate. This copper sulfate dissolves in dilute sulfuric acid to absorb the impurities, which are phosphine gas BH3 and hydrogen sulfide gas, and so the acetylene gas will be collected above the water as shown on the screen. So we have good reason in this point. Acetylene gas is passed over copper sulfate solution in dilute sulfuric acid. The answer: to remove phosphine gas and hydrogen sulfide gas, which are produced from the impurities found in calcium carbide. The second way for preparation of acetylene or ethine is the preparation in industry, which is prepared from natural gas by heating to high temperature higher than 1400 degrees Celsius, then fast cooling that we call rapid quenching for the product. The equation of the reaction. As shown on the screen, 2 molecules of methane by 1500 degrees Celsius, then rapid cooling that we call rapid quenching, forms acetylene gas and 3 moles of hydrogen are produced. Now we are going to discuss the chemical properties. And we have give reason in this point. Alkynes and alkenes are more active than alkanes because the presence of weak pi bond which is easily broken, while that in alkene 1 pi bond, while in acetylene 2 pi bonds. Now we are going to discuss the combustion of acetylene gas. As the equation proceeds on the screen, on combustion in limited air, that acetylene molecule reacts with limited amount of oxygen. As the equation proceeds on the screen, 2C2 plus 3O2 gives carbon dioxide and water and carbon. While on combustion of acetylene gas in excess air, excess oxygen gas, as the equation proceeds on the screen, 2C2 H2 plus 5O2 in excess air gives 4CO2 and 2 water and large amount of heat 3000 degree, which is used for welding and cutting metals. My dear student, as shown on the screen, if we brought the calcium carbide over the water in order to produce the acetylene gas, the acetylene gas is produced. And so, if we are going to close burning match to the mouth of the flask, we will find that the carbon dioxide and water produced and some carbon produced if it is limited amount of air. So, my dear students, the heat evolved reaches about 3000 degrees Celsius. Therefore, the oxyacetylene flame is used in welding and cutting metals. Now we have give reason in this point. Ethane gas burns with a smoky flame in limited amount of air. The reason for that because carbon doesn't completely burn it. Now we are going to discuss the reactions of acetylene. The reaction of acetylene as any alkyne or alkenes takes place by addition reaction, where the pi bond is broken. So the presence of 2 pi bonds in acetylene make it react by addition in 2 steps. The first type of reaction is hydrogenation. Hydrogenation occurs by heating in the presence of finely divided nickel. As the equation proceeds on the screen, the first step takes place when the hydrogen molecule is added to the acetylene. 1 pi bond is broken and forms ethylene gas. Then the second hydrogen mole, when added, breaks another pi bond and forms ethane, as alkane is formed. Second type of reaction, which is halogenation, is the reaction with halogens, fluorine, chlorine, or bromine. We find that they react vigorously, and this reaction accompanied by heat and light. As shown on the screen, now we are going to put the halogen over the acetylene gas. Here we find that the reaction is vigorously as you show on the screen, and here the bromine molecule or the halogen molecule enter the alkene and forms the dibromo or dihalo alkene and then the alkane. Here, my dear student, when bromine solution is added to the acetylene, here the acetylene gas breaks the pi bond in it, and bromine molecule that has red-orange color will be removed its color, as the following animation will show. As shown on the screen, my dear student, if we bring alkane and alkyne and we add bromine solution over them, we find that the alkene or alkyne, if you add halogen red bromine on it, the red color will be removed, while in alkane the red color of bromine will be remained. So here the alkane compound, the red color remains when adding bromine on it as shown on the screen. Now we are going to add the bromine over the alkyne. Here we find that the alkyne molecules will remove the color of bromine. So bromine is used to test for the unsaturation of the compound, whatever it is, alkene or alkyne. So we can differentiate between alkene and alkane or alkyne and alkane by removing the color of bromine on putting on it. As the equation proceeds on the screen, now acetylene plus bromine, it gives 1,2-dibromoethene, as the pi bond is broken and the bromine molecule added to the 2 carbons that have the pi bond between them. Then when we add the second molecule of bromine, it will break the pi bond that remained and forming 1,1,2,2 tetrabromoethane as shown on the screen. Now the reaction with halogen acid. As shown on the screen, acetylene reacts with hydrogen bromide and breaks one pi bond and forms vinyl bromide, or we can say 1-bromoethene, its IUPAC name. When adding the second molecule of hydrogen bromide, it breaks another pi bond and forming 1,1-dibromoethane. The next type of the reaction is the reaction with water, which is called catalytic hydration. As the acetylene molecules react with water, in the presence of mercury sulfate and sulfuric acid concentration 40% and heating to 60 degrees, it forms an unstable compound which is called vinyl alcohol, as shown on the screen. And then this vinyl alcohol will be rearranged as the hydrogen of the hydroxyl group is moved to the other carbon and forming the molecule that shown on the screen that we call acetaldehyde or ethanol. This reaction is used to prepare ethanoic acid or acetic acid by oxidation of acetaldehyde. As shown on the screen, acetaldehyde or ethanol, on oxidation it gives acetic acid. This oxidation takes place by oxidizing agent. Here it is acidified potassium permanganate, or we can say potassium permanganate added on it sulfuric acid to make acidic medium. This potassium permanganate has violet color, so its color will be removed. And the acetic acid here produced can be used for preparation of methane. As we know, my dear student, in the alkane, we add sodium hydroxide first to acetic acid to form sodium acetate. Then we make dry distillation of sodium acetate, we can obtain methane gas. My dear student, ethanol can be obtained from reduction of acetaldehyde or ethanol. So if we make reduction of acetaldehyde or ethanol, it gives ethanol that can be used for obtaining ethylene gas, as we took in the last period. On adding sulfuric acid at 180 degrees on ethanol, we can obtain ethylene gas by dehydration reaction on removing the water molecule from ethanol. Now, my dear students, we are going to discuss the cyclic hydrocarbons. We are going to discuss first saturated cyclic hydrocarbons. They are closed chain hydrocarbons called cycloalkanes. Their general molecular formula CnH2n. The nomenclature of cycloalkane is similar to open chain alkane, but we put the prefix cyclo in case of cycloalkanes. As shown on the screen, this molecule contains 3 carbon atoms, so we call it cyclopropane, its IUPAC name. Another molecule here, as shown on the screen, contains 4 carbon atoms at the corners, so its IUPAC name will be cyclobutane. Another example contain 5 carbon atoms and general formula CnH2n, so C5H10. Its name is cyclopentane. Another molecule here, it contains 6 carbon atoms, and we apply the general molecular formula C6H12 now, CnH2n, and the corners contain carbon atom, and each carbon joined by 2 hydrogen atom, so we form the cyclohexane. We have given reason in this point, my dear students. Cyclopropane and cyclobutane are very active compounds compared with the open chain alkanes, because the angles between the bonds in cyclopropane equal 60 degree and in cyclobutane equal 90 degree, which are less than 109 degree, which means this 109 found in open chain alkanes, so leading to weak overlap between the atomic orbital, so form weak bonds. So, for example, cyclopropane forms with air burning mixture, while normal propane is less active. Another give reason in this point. Cyclopentane and cyclohexane are stable compounds. The reason for that is that the angle between the bonds near 109 degree, which are found in alkanes, that leading to strong overlap between the atomic orbitals, so form strong sigma bonds. Now, the second class of cyclic alkanes is unsaturated cyclic chain hydrocarbons that we call aromatic hydrocarbons. The ancient scientists differentiate between 2 kinds of organic compounds. Aliphatic compounds, they are organic compounds derived from fatty acids which contain high ratio of hydrogen. And methane is considered the parent member of these compounds. And second type is called aromatic compounds. These compounds are produced from some resins and natural products which having a characteristic odor and contain less number of hydrogen atoms. The aromatic benzene is the first member of these compounds. My dear students, the aromatic compounds may contain 1 or 2 or more benzene rings besides their various derivatives. For exercise, write the molecular formula for the following compounds. Aromatic benzene. If you draw the structure formula of aromatic benzene as shown on the screen, C6H6, at the corner contains 6 carbon atoms, each one contains 1 hydrogen atom, and the presence of double bond and single bond alternated as shown on the screen. Naphthalene, here as shown on the screen, 2 fused rings, and the molecular formula of naphthalene is C10H8. Anthracene, the third molecule here, as shown on the screen, 3 fused rings of aromatic compounds, where the double bond and single bond are alternated in these 3 rings, and forming molecular formula C14H10. My dear student, notice that the benzene used in car is the gasoline, which is completely different from the aromatic benzene. Now, my dear students, we are going to discuss some questions. Choose the correct answer. The number of hydrogen atoms in alkyne having 5 carbon atom is what? Is it 5, 8, 14, 12? If you think about it and you apply the general molecular formula of alkyne, which is CnH2n minus 2, so the answer it will be 8. Next point, When water dropped on calcium carbide gas, what is produced? Is it methane, ethene, ethine, or ethane? If you think about it, yes, it will be ethine, C2H2 that we call acetylene. Next point, the number of carbon atoms in alkyne having 10 hydrogen atom is what? Is it 14, 7, 6, 5? If you are going to think to solve this question, you have to apply the general formula of alkyne, which is CnH2n minus 2, and you will find that the answer it will be 6. Next point, saturated cyclic hydrocarbons, which composed of 3 carbon atoms or more, called what? Is it alkanes, cycloalkanes, alkynes, aromatic compounds? Yes, if you think about it, yes, it will be cycloalkanes. The value of the angle between the bonds in cyclobutane is what? Is it 109.28 or 107 or 60 or 90 degree? If you think about it, yes, the answer it will be 90 degree. Next point, the most active compound from the following compound is what? Is it cyclopentane, normal propane, cyclopropane, cyclohexane? If you think about it, my dear student, it will be cyclopropane. Next point, the molecular formula of alkyne having 10 hydrogen atom is what? Is it C5H10, C6H10, C7H10, C4H10? If you think about it, yes, the answer it will be C6H10. Next point, the number of sigma bonds between carbon atoms and hydrogen atoms in an alkyne having 3 carbon atom is what? Is it 5 or 3 or 10 or 4? If you think about it, yes, the answer it will be 4. The number of sigma bonds in an alkyne having 4 carbon atom is what? Is it 4, 8, 12 or 10? If you think about it, yes, the answer it will be 10. Next point, alkynes are considered from what kind of hydrocarbons? Is it open chain unsaturated, unsaturated cyclic, open chain saturated, or saturated cyclic? If you think about it, yes, it will be open chain unsaturated. The molecular formula of alkyne having 6 carbon atoms is what? Is it C6H12, C6H10, C6H14, or C6H6? If you think about it, yes, it will be C6H10. Next point, the number of sigma bonds between the carbon atoms in an alkyne having 5 carbon atoms is what? Is it 3 or 5 or 6 or 4? If you think about it, yes, the answer it will be 4. Next point, the molecular formula of an alkyne having 16 atoms is what? C7H9, C6H10, C4H12, or C5H11? My dear student, if you think about the answer, yes, it will be C6H10. Next point, compounds having molecular formula C5H8 is considered from what kind of hydrocarbons? Is it unsaturated aliphatic, saturated aliphatic, saturated cyclic, or A and C together? If you think about it, yes, the answer it will be unsaturated aliphatic. Next point, in alkynes, each compound exceeds the previous one by what kind of group? Is it CH3, C2H5, CH2, CH3, CH2? If you think about it, yes, the answer it will be CH2, which is methylene group. Next point, the number of methyl groups in 4-methyl 2-pentyne is what? Is it 3, 2, 5, 4. My dear student, to answer this question, you have to write the structural formula of the molecule and then count the number of methyl groups. So the answer here will be 3. Next type of question, give IUPAC name of. If you look at this molecule, my dear student, and you count the number of carbon atoms, it will be 4, and numbering it from the nearest to the triple bond, you will find that the compound name, IUPAC name, will be 3-bromo-1-butane. Next molecule, as shown on the screen, numbering of carbon atom start from the nearest carbon to the triple bond, so its name will be 3,4-dichloro-1-butane. Another molecule as shown on the screen, if you name it according to the IUPAC system, so it will be 4-bromo-3-methyl-1-butane. Next molecule here, its name is 4-bromo-3-chloro-1-butane. Another example as shown on the screen, if you are going to name it according to IUPAC system, yes, it will be 3-ethyl-4-methyl-1-pentane. Next one, if you are going to name it, yes, it will be 1-bromo-4-methyl-2-hexane. Yes, this molecule, it will be 2-methyl-3-hexane. This molecule, it will be 3,3-dimethyl-1-pentane. Next type of question, write your objection on the following nomenclature. 1-chloro-4-butane. If you think about the answer to this question, you have first to draw the structure formula of the molecule, and then you are going to numbering the carbon atom in the right way. So its name will be 4-chloro-1-butane. Next one, 3-ethyl-1-butane. If you are going to draw it in the structure formula and numbering carbon atom according to nearest to triple bond, so length of the chain here will be 5, so its name will be 3-methyl-1-pentane. Next one, 2-methyl-4-butane. If you are going to think about it, you draw the structure formula and then numbering of carbon atoms near to the triple bond, so its name will be 3-methyl-1-butane. We have reached to the end of our program today. I hope you understood all the points that we discussed today and the chemical reaction that we discussed today. So till we meet again, my best wishes for you.